Okay, so today we're going to cover another lab. We are going to focus on the iris data set, and we are going to try to solve that data set using the sklearn framework. So to do that, I'm going to use the GPU boxes that we have set up. So the first step is I'm going to show how to log in basically via SSH to a GPU server that you have somewhere on your network. All right, so I'm going to use my laptop here. We're recording with Camtasia. So double click on the putty. To log into our GPU boxes, we are going to SSH into 205.215.77.244. All right, and we're going to be using port number 22. So I'm going to click on open. I'm going to log in. We've set up some accounts for this assignment. Okay, and then we're going to type in the password. I mistyped it. Okay, so all right, so once we are here, all right, we can basically all we have to do is we can navigate. This is just a standard Linux operating system, so we can check where we are. Basically, our full path is home Ricardo. That's my account. And we've set up a few folders in here. We have the cybersecurity folder, so this can be where you load your materials to do the assignment. This is your desktop. This is the standard downloads folder, and this is public. So public is the folder where we've actually placed on these machines all the data. So it's possible that we only really have 3 GPU boxes physically here. We will also have a few GPU boxes in AWS virtually. And in another video, I'll show how to set that up and how to connect to that. Here, to access the, since several students can log in basically to this GPU box, we have a public folder where we have all the materials, and then students will have to log in with their credentials and then copy the files from public into their own home folder. All right, so basically, the files, let's say that the files are here in public, so I'm going to log in there or cd into that. All right, and if I do pwd, you can see the address is home. All right, so anyway, so I just logged in. And now you can see this is where the folders are located. We have our cybersecurity folder. That is the one that we are going to use. So I can log in into that one. Okay, if I do pwd, right? So that's basically where I'm going to put my files. However, you can put your files wherever you want. You can put them on the desktop somewhere, etc. For this example, I'm just going to use this. So what we need to do is we need to copy the files from a public folder that we have established. That public folder is located at home powers public data sets. Okay, so data sets. All right, and then so we're going to copy all the files located in this folder, and we are going to move them into home, your user account. So in my case, I'm using this one, and then cybersecurity. Like I said, this can vary. Some people may like to put their files in on their desktop. Okay, so once this is ready, you can just hit enter. and now the file should be copied into that folder. So if I look in there now, I'm in it. All right, so I can do ls, and here we have data set, so I can cd into the datasets folder in here, and you can see. All right, so let me clear this out. Okay, so I'm going to do ls-l, and you can see we have basically just a few data sets here. We have a fishing data set for fishing data. We're going to be using this later on. MNIST is one of the standard data sets for machine learning education, so we're going to spend some time on that one. It's to do with image processing. We will also be working on a biometrics data set, which is also image processing. Then we have KDD, which is a network intrusion detection data set. We have Iris, which is the one that we will be using today, and then later on we will add a few more data sets as well. So let's just go into Iris. All right, and you can see here we have a few files. We have a plot. We have the Iris sklearn code, which is basically kind of like the starter code or the solution for this. We have the Iris TensorFlow, and then we have the actual CSV file. All right, so let's quickly take a look at the CSV file. We can do cat iris.csv. All right, and you can see that's kind of the data, the way it looks. We have basically the first, let's say I take this one sample. So this is a sample for a tree, Iris virginica. And so it's got 4 columns, basically. The first one is feature 1. They're comma separated. The second one is feature 2. The third one is feature 3. The fourth one is feature 4. And then finally, Iris virginica here is the class. Okay? So once we've completed this part, we've looked at the data, we know where it is. The next step is we're going to set up our Python environment. So in our case, what we're doing is we use Conda or Anaconda. So in Linux, using Anaconda is something I would highly recommend, even though it might be difficult to use in the beginning. It is very useful because versions of sklearn, of Python, or TensorFlow are always changing. So they're all, you always have, for instance, a classic example of this, if you want to do reinforcement learning with Python Gym, you need to have a specific version of Python, 3.5. But a lot of those, default Python versions are 2.7, or you might be using 3. And so by using Anaconda, it's really useful. I will do another little presentation on Anaconda itself, but it allows you to create multiple environments, right? Multiple environments that you can always just load, and you have there all the versions of the software that you need for your specific task. So in this case, we're gonna enter the environment for this. All right, so I'm just gonna do source home powers, which is the administrative account, Anaconda 3 bin, and then activate space tf dash gpu dash CUDA 8. So I have a typo here. All right, let's try again. There we go. All right, so as you can see now, the prompt has changed a little bit. It now indicates that we are in this CUDA environment, all right, which should have all of the all the files that we need. If we do conda environment list, right, you can see that this provides a list of all the environments that are available. So currently we only have one, but if let's say you had let's say here we're using CUDA libraries 8 and Python 3, and then another one we want to use Python 3.5, we could have another entry here that says, you know, Python 3, py 3.5, something like that. So these are the environments, and we just entered one of them. All right. So now we have everything that we need to start our lab. All right. So what I will do with this one, to keep it simple, I'm in the environment, but keep in mind, in the file system itself, I am at the location of the files, right? So here's my iris.csv is the file that I want to use. So the first example that we're going to do is just we want to use machine learning to build a model that can train and test with the iris data set, right? So that's really all it is. So I've explained how iris works in some of the previous slides. I just showed it also, right? So keep in mind, if I do this, right? So iris has 150 samples, right? It has 3 classes. There's 50 samples per class, and each sample has 4 features. So basically, these have to do with the length of, you know, I think the length of the, like, let's say of the branch and the tree trunk or the leaves, you know, little things like that. So they're just measurements, 4 measurements for each plant, and based on, you know, bigger leaves might be setosa, and then smaller leaves might be versicolor or something. All right, so that's really the idea. So we're going to take about 70% of these samples, we're going to randomize them, and we're going to use them to build a model, and then we're going to leave, you know, 30% of the samples, randomize them as well, and then we're going to use the model to predict what those samples should be. Once we have the prediction, we will be able to compare the predicted with the actual value. Okay, so that's really our goal. So to do that, we can create a Python script. All right, so that's kind of what I'm going to do. I'm just going to say nano solution, and I'm going to say sklearn. sklearn.py. So I'm going to create a simple Python script to solve this. All right, so I'm using Nano. You can use other editors. You know, there's plenty, but I'm just keeping it simple with Nano. All right, so here in this, so I just created the file. So I'm going to add a comment here. So it's Python. This is a comment, or let's just actually just say this is solving iris with sklearn. So sklearn, just as a reminder, sklearn is a standard machine learning library in Python. It's widely used in combination with NumPy and Pandas. This is a library that doesn't necessarily solve big data problems, but it's still a very useful one. All right. Remember, when we want to deal with deep neural networks and big data, we're going to use TensorFlow. But actually, we can combine sklearn and TensorFlow together, right? So for instance, if let's say somebody has a lot of experience with sklearn, they can solve a lot of the problem with sklearn and then just solve certain parts with TensorFlow. All right? But TensorFlow does have usually the same functions as sklearn, so they can be used together. All right, so now that we have this, so the first part, what usually takes quite a bit of time, is just adding the libraries. All right, so usually I'm just going to add all the libraries, but I'll describe them a little bit. So, whenever you want to import a library in Python, you use the import command. One library that we're going to use is matplotlib .pyplot. So this is a library that we want to use because it's very helpful, especially if you're creating reports or you just want to visualize your data, that you want to create graphs. And so matplotlib allows you to do that. All right, so that we don't have to type up everything in Python, you can call the library and then just say as PLT, for instance, and that basically means that we've given it a name. And so that whenever we want to reference this library now, all we have to do is use the PLT part. All right. Another library that we'll be using later is pandas. This is a very, very powerful library. So something that might take you, 200 lines of code and a lot of for loops may be done easily in pandas with just 5 to 10 lines of code. Right? Because pandas is designed for data manipulation, so it's certainly a very important library for the data scientist or machine learning expert. Another library that we're gonna need is gen from text. So we're gonna import this library from NumPy. NumPy is basically a numerical processing library. All right, you can think of it as MATLAB, if you've ever used MATLAB in Python, right? So it allows you to do a lot of operations, and it's got a lot of built-in functions. So in here we're going to say, from NumPy, we are going to import gen from text. And this is, we'll be using this shortly. This will allow us to take the information in the CSV file and convert it into, our matrix, right? So everything in Python will be a variable, basically, and it's really a matrix whenever we're talking about machine learning. So any data that we read from files will be converted into a matrix, and that is a common theme in machine learning. After that, we're going to have a few algorithms for machine learning. We're going to do from sklearn. So you can see now I'm using the sklearn library. This is something that has to be installed. From sklearn, import SVM. All right, so we're going to import the support vector machines library. Okay. We're also going to use logistic regression, so we should be able to do from sklearn import logistic regression. Logistic regression. All right. Now, once we have these two libraries, and actually here, sorry, it should be from sklearn dot linear model, linear underscore model, import logistic regression. All right, once we've imported those two libraries, we are almost ready, right? We just need to do a few things. So whenever we have a data set, we're going to need to read the data set, right? Then if we have classes that instead of having numbers have like words. So for instance, if you remember in our data set, we had for the classes the word Virginica, versicolor, etc. Machine learning algorithms can't really process strings like that. We need to convert everything into a number. And so to do that, we're going to use a tool called the label encoder. Right? I'll show how that works later, but the label encoder basically can take care of that. So to do that, I'm going to create from sklearn dot preprocessing. So if you remember from the discussions in the lectures, preprocessing is one part of the machine learning pipeline. Usually one of the first ones. Before we get to the models, we need to preprocess the data in some way. So in this case, the preprocessing will involve taking versicolor, Virginica, and the third class and converting them into numbers like 0, 1, and 2. So once we do from sklearn dot preprocessing, we do import label encoder, so this will be the library for that. And we are also going to use the standard scaler. scalar, which will allow us to basically, scale our data. And I'll talk a little bit about this, but it's basically normalizing the data, right? So, if you have different features, so for instance, features like that are port numbers from 0 to 65,000, and then you have other features that go from 1 to 5 or 1 to 10, those two ranges are quite different, right? One is really large, one is really small. So by scaling the data, basically everything is going to be placed in a scale from 0 to 1. So the 0 to 65,000, now that would be proportionately placed in a scale from 0 to 1, and the same goes for the 0 to 10. Those values will be proportioned to a scale from 0 to 1. Okay? So then that's the standard scalar. Now, additionally, we need, since we are going to train with 70% of the data and test with 30% of the data, we need a tool to do the split. All right, so to do that, we are going to import the library from sklearn.model selection. We are going to do import train underscore test underscore split. Right, and this is the function that will help us to do the split, train test split. And finally, the last part, there's a video on how to evaluate machine learning algorithms, right? So usually when we discussed this in the lecture, we talked about the metrics that we need to use, like the accuracy, precision, recall, and F measure. So these are the equations or the techniques that we use to measure and evaluate the the performance of our machine learning algorithm. So to do that, all of those are located in the sklearn library. sklearn.metrics import. And then here we can just list out all of the different metrics that we will use. So for instance, we will use accuracy score. And then we are also going to use the confusion matrix. And then we're also going to use the F1 score. And then we're going to use the precision score. And finally, the recall score. So these are all just different metrics that we can use to kind of assess how well the intrusion or the machine learning algorithm is working. All right, so that's basically the library. So we're done with that. Usually, what I recommend when you create a Python script is to add, separate with comments, create a line basically. I also sometimes suggest that you can do something like this. You can do print. This is Python 3. So print is like that. It should be done. Right, and that just tells you that your algorithm has finished, so it doesn't get stuck in a loop or something like this. It's kind of helpful. All right, so now we have the libraries. We have this. All right, so now that I have this, the next step is to basically to read the data, right? So we want to get the data, and to do that, we are going to use the generate from text function. So this library that we have here, right, this import, we're going to use down here. So gen from text is a function. We have to specify some parameters. It basically reads in data. So we're going to take data from the text file, kind of slice it out in a specific way, and assign it to a matrix. So in our case, I'm going to call it features. All right, so that's basically the X matrix that we're reading in. All right, and then we're going to select the file that we want. So in this case, it's iris.csv. Right, so that's the file that I've created. Usually you want to tell the delimiter, so it could be like tabs or comma separated. So in our case, the file was comma separated. So delimiter is a comma. So with a single quote, I'm just going to put in a comma here. Okay. Then I'm going to select which columns I want. So use columns, and I need to specify which columns I'm using. So I could do this in several ways. One way could be just to indicate that I want column 0, 1, 2, 3. Why do I do these? If you remember when we did the cat, we saw the file. So this is a good opportunity to let's save. So remember, we're using Nano. So whenever we want to save, I'm just going to do Control X, and then I'm going to hit Y, and then the name is there, and I'm just going to hit Enter. Right? So that saves it. So this gives me an opportunity to look at the data. Remember, I am reading this data, right? So when I say I want columns 0, 1, 2, and 3, I mean I want these exact columns. I don't want 4, right? Because that would be the class. And so I'm saying for everything, of all the data that you're going to read 0, 1, 2, and 3. Those are the columns. Okay? So that's one way of doing it. However, that's easy when you have, so now let's go back. So I'm going to type nano solution sklearn py again. That's one solution. However, let's say that later on we're going to use the NSL KDD dataset, which has about 40 features. Or other datasets that have even more, like MNIST will have 784, and others, right? May have even more. The biometrics one, I think, has about 10,000. So you can't start typing all of these in, right? So another more efficient way is to just iterate in a loop, right? So we can say, for instance, for I in range, so for I in range, where the range is from 0 to 4 not included, I'm going to get these values. So this is called a comprehension, a list comprehension in Python. It's basically you can write a for loop anywhere, it evaluates, and it just returns something. But what does it return? Well, that's the tricky part here that you have to specify. I want you to return I. All right, so if we go back, so so I'll repeat it. So this is called a list comprehension in Python, right? So it basically takes a for loop, I in range from 0 to 4, and it's going to evaluate it. Okay, so, but what does it actually print out in the list comprehension? It'll print out all the i's. So all you have to do is put the I in front, and so that way you iterate for I from 0 to 4, and it's going to print 0, 1, 2, 3, 4. The same thing I had before. Okay? So that basically does it. That gives us the columns that we want to select. All right, the next step is we're going to select the data type that we want in here for the data that we are reading. Oops, not there. So in this case, it's going to be data type equal float. All right, and finally, because the text file, the CSV file that we read in has a heading, right? So the first row is actually the names of the column. So we want to skip that, and so we can do that simply in gen text by saying skip underscore header. Oops, it's doing this. So let me move this down. Okay, so we're going to say skip header, and that's going to be equal 1. So it basically means that it skips that first row it doesn't use it because we can't use it, so we don't want it in there. All right, once we've done that part, the next part is to read in. So at this point, we've sliced the features, the X component. Now we need to slice the Y component. All right, so to do that, we are going to take class value. So class value, again, I created this variable. It's going to hold just, it's a column array basically, or a column vector. It's just going to hold the classes of the features. So I'm going to do gen from text, okay, the same function with pretty much the same parameters. I'm just going to say iris.csv, so iris.csv, comma, delimiter, so comma, delimiter, which will be the delimiter as well, again, so comma. I'm going to select the columns again, so in this case, use columns equal, and in a parenthesis, I'm going to specify the -1. Right, so whenever you specify a -1 here, that means the last column, basically, the last column in the CSV. All right, so we have that, use columns -1, that's the last column. We have the data type, which will be string in this case because it's a versicolor, the word versicolor, Virginica, etc. So we have to read in a string. We will later use the label encoder to change that. And finally, we have again just skip header equal 1 so that we can skip that header. So once I've done this part, and we're actually pretty close to finish with machine learning with this algorithm, the next step is to convert the class value currently holds some value. So let's say, for instance, I'm going to do print class value. So let's just run this. I usually do recommend that you run the algorithm as you're typing in things. So at this point, we have enough statements, right, that we should be able to run it. So I just want to print what the contents of class value. So I'm going to save it again. So Control X, Y, Enter. All right. So I'm going to hit clear here, and now to run the script, instead of typing nano, I'm just going to type Python, and let's see if it gives us any errors. All right, and there you go. So it actually printed out everything. See, that's why it's handy to have that done there. That tells you that it didn't break anywhere. And it's printing the contents of that class value, right? So as you can see, it's got the words in there, the labels. All right, so now that I'm done with this part, let's go back to the script. Okay, let's finish it up. So once I print, I don't need to print this every time, so I'm just going to add a comment in here and kind of get rid of it. All right, now I'm going to do the labels part. So I'm going to use the label encoder to change the labels from the words Virginica and versicolor to actual numbers. So to do that, I can type labels. And actually, I'm going to delete this. Okay, I'm going to do labels equal label encoder. Right, that's the label encoder that's up here, this function. So label encoder dot, and now, so whenever we use these functions in sklearn, the uppercase label. All right, so whenever we use these things, so whenever we use these functions in sklearn, they usually have the object, rather, the object like label encoder or SVM, they usually have three main functions. They have fit. So whenever you're using these objects in sklearn, you can they're usually associated with certain functions. So some of these functions are fit, which is basically the one that you use to build a model, right? So whenever you give it the training data, you fit the data. So you use fit. Once you've built the model and now you want to use it with the test set, then you say predict. So that's another function. And there's one that's actually fit predict or fit transform, which allows you to do everything at once. All right. So this is the example, for instance, with label encoder. We could do label encoder fit and then label encoder transform, but we can just basically do the same all together. So to do that, I'm going to create, I'm going to call fit transform, and this will convert the data from class value, the words, into the vector now, which will have numbers instead. So now we can go ahead and print this one. So I can do print labels, and once again we can visualize the contents of this variable. So I'm going to do print labels, Control X. All right, I'm going to run it again. And you can see now these classes have been converted into zeros, ones, and twos. Right? So that's an important step. Once I've done this, we can go back to the code again. And again, I'm just going to delete that. And now that I've created the labels, the next step I want to do, and it's not a bad idea to add a line here, because this is, logically something different, right? So now we read the data in this segment, and now in this segment we're not reading the data anymore, but we're pre-processing the data or transforming it. So the next step that we want to do is we want to scale the data. So this is, remember, when you have, let's say, one feature that goes from 0 to 65,000, another one that goes from 0 to 10. Right? You kind of want both of them to be in the same scale, so we're going to create. Now this does not apply to the classes, it only applies to the features. So we're going to do here, instead of using features, we're going to do features normalized. So features normalized. We're going to use now standard scalar, right, as our function. So I'm going to go to features normalized. All right, and I'm going to apply standard scalar dot fit transform, and I'm going to transform the features vector. So I'm going to take this one, and now I'm going to normalize it. So I'm just going to do features. Okay? Once that's done, we're almost done with pre-processing. The last step is simply to create our training and our testing sets. Now remember that we already have two sets, labels and features normalized, right? So these are the two that we're going to use. But now we need to create two of these and two of these. So we're going to end up with 4 sets. So we're going to have labels training, labels testing, and we're going to have features normalized training, features normalized testing. Now we don't have to worry about aligning them because we just use the function, this function, train test split, which takes care of everything. So I'm just going to do train test split. All right. The inputs to this function will be features normalized, also the labels. So these two are the inputs, labels, and we specify the test size. So by doing this, we're basically saying we want 70% for training, 30% for testing. So test size is equal to 0.30. Right? So that means training will be 70%. This also randomizes the data, so we can say we can play around with a variable here, random underscore state equals some number. Right? So by adding this seed number, we can always make sure that we always end up with the same randomization. Right? So that's why you have a number here. Right? So, or sometimes you can also set it so that it's always different as well. Right? So we do random state 0. Okay. So that should be ready for that part. And so now this function will return 4 matrices. Right? It'll return xtrain, comma, xtest, comma, ytrain, comma, and ytest. So it returns these 4. So now they're very clear. We use xtrain and ytrain together, right? So that's the features and the labels, and then we use xtest and ytest, right? So 70% of the data should be in this one and this one, and 30% of the data should be in this one and this one. All right. So now that we've completed this part, let me move on. So now I'm going to go to the next line. Okay, we're done with pre-processing. Okay. And now we're ready to do a machine learning algorithm, right? So in this lab exercise, basically, for this part, I will do one of the examples. And then as part of the assignment, the students will have to basically use other algorithms, right? And compare the results, basically. So they'll have to use at least 4 algorithms. So for instance, they can use I'll show an example with support vector machines, so they can also add other algorithms like logistic regression, decision trees, random forest, KNN, etc. Anything that's available in sklearn. So the students will have to read the notes and read more information on how to implement them with those other ones. But I will show just one, right? So that's in the assignment here. So basically, analyze iris data with 4 or 5 machine learning algorithms and compare your results. All right, so here I'll just show the example with support vector machines. So you can always, it's always good to maybe add a little comment here and just say something like, SVM. So SVM is one of the very powerful machine learning algorithms. Before deep neural networks, it was actually the most powerful, right? A lot of people spent a lot of time learning about its support vector machines because it was theoretically very well founded, very interesting algorithm, and it was good. But it was a little bit difficult sometimes to use because you had to really tweak it had more parameters that in an optimization you had to kind of adjust. Here, as far as the parameters, we're just going to use default parameters, so we're not really going to worry about them. I'm doing SVM, for that reason, right? So that you don't have to worry about tweaking it. The other algorithms require usually less tuning, and so they're easier to use. So here, but this is basically the pipeline. So if you remember at the beginning, so let me save this. Right, so if you remember at the beginning, I did sklearn import SVM, and I also did sklearn.linear model import logistic regression. So I've added 2 algorithms here just to show how you need to do it. But how the student needs to solve this, but actually you will need to add at least two more libraries for 2 additional machine learning algorithms. Right? So as I said, you'll have to read the notes, or the slides. So how do you do it? Assuming we have that library, we can create an object, let's say svm1, just some object, and then we're going to say svm dot, add a space here, and we select SVC, that's the name of the version of the support vector machines that we will be using. Once we do that, we can build a model simply by saying svm1 dot fit. Remember, fit is the function that basically trains, right? So you can say train, so you said fit. And what do you train on? You train on the train data, so you give it then the xtrain data set and the ytrain data set. So you give it the samples and the labels associated with it. Don't worry about the alignment of them. The function train test split takes care of all of that. So it's basically making sure that these y's are aligned with these x's, so they correspond to each other. And that's really one of the greatest things of this, because if you imagine if you have to do this by hand, write your own code, you have that headache, right? Are they aligned? But with this, they're basically aligned. So that's really, so far we have done very little math, or machine learning, sorry. We've done mostly just, pre-processing. But at this point, these two lines are actually the machine learning component. We created the support vector machines object, and now we've trained it. It's ready. So it is actually trained. So all that's left now is that we are going to predict on the train set, and then we need to evaluate. Now, so what we need to do now is we need to take svm1 and apply it to xtest. Xtest will give us some results, and then we need to compare those results to ytest. All right, and that's it. And given that, we are done basically with this example for support vector machines. So to do that, now I'm going to predict. So let's say, since we're using ytest here, I'm going to do ypred. Oops, not there. Ypred. I'm going to create this variable, and this variable basically will have the predictions. All right, so I'm going to call svm1 dot predict. So I give it as its input xtest, right? And it's going to predict labels that will be assigned to ypred. Now the last part of all of this then is, once I have the predictions, I can evaluate them. So we need to have some kind of a function. Let's imagine that we have a function. We're going to call it a magical function that gives us all the results, right? How handy would that be? All we have to do is we have to give it the y vector of the predicted values and the y vector of the actual test set. And it's going to compare apples to apples. So to do that, let's create a function. We're going to say print stats, like statistics or results. And we're just making up a name here, metrics. Right? So we call it like that, and then its inputs are basically ytest, which is the actual labels for the xtest dataset, and also ypred, where ypred are actually the predicted values. So it's going to compare them. So you can imagine that this looks, I'm going to delete this, but let's imagine that the classes are 0, 1, and 2. So ytest is 0 and ypred is 0. And then the next one is 1, and this is also 1. So there we have a match. But the next one is actual 1, and it predicted is 0. So there you have an inconsistency, an error, if you will. Right? And that's what this function needs to look at this data like this and predict, okay, the accuracy was, 66%, right? So 2 out of 3 were correct. All right, so that's what we're going to do. So I'm going to delete this. But this function, we still need to create. So currently, this function, takes those two values and now needs to do something. All right, so that means that we need to create this function. So let's just add it somewhere. Let's say here, we're going to create a function. And the great thing about this is I do suggest that you should always keep some like starter code. This function you can reuse for any machine learning algorithm and even for the deep learning algorithms. You can actually use it there as well, the deep learning algorithms. All right, so let's go ahead and now define this function. So in Python, to define a function, you type def print stats metrics, right? And this takes, as we stated, y test, y pred. We had a colon and then indentation, so 1, 2, 3, 4. All right, so the easiest thing that we can do here is just now, where are these defined? These are actually defined in the library. So if you remember, we did from sklearn metrics import accuracy score, confusion matrix, F1 score, precision score, and recall score. So this is what we're going to be using here. So let's just start with one. Let's start with accuracy score. So all we have to do is very simple. We do print, right? And then we're going to specify the string that we want to print out. So we're going to say accuracy, we can say accuracy is, and then we can specify here the value. So I'm going to use a format string. I'm going to do percentage 2 or dot 2f, right? So 2 decimal and float 2.f. And then now, and that just basically means that that's the formatting that we're going to use. Now followed by a percentage, and then we plug in the actual value that will be placed in here. So to do that, we call the function accuracy score. So accuracy. So this is in our library, in our imports section in our libraries. We imported several, including accuracy score. So accuracy underscore score, and then we give to this the values. Basically, this is where we compare y test and y pred. Okay, we had one final parenthesis, so we have this parenthesis closed here and these two closed, and that's it, right? So now we are ready. So we can scroll up. So accuracy score is this one. We're going to use all these metrics, but let's just try it out with accuracy score. All right, so I'm going to scroll down here. All right, so that's where the function is called, and we call this function. All right, so let's save it and let's run it. So Control X, Y, Enter. All right, so now we can run this by typing Python solution sklearn.py. Everything works. There it is, and you can see here now accuracy was 98%. Now you might see a this Python is always doing this in sklearn. It's a future warning, or sometimes it says something is deprecated, etc. But we can ignore it. It worked fine. So it just says accuracy is 0.98%. So basically that means what? That we trained with 70% of the data, built the model, then we applied the model to 30% of the data, and 98% of the samples in that test set were correctly classified. All right, so now that we have done train, I do want to do all of these because they're very important. So I'm going to go to, and then once we finish this function, the rest can be done by students, solve the lab. Remember, the goal will be to analyze iris dataset using several machine learning algorithms. So what I would say is, for the next one, you would do something like this. So add a new line, and now I'm gonna add a comment, but basically you would say something like logistic 1, right? And then, however you create logistic regression, you have to figure that out. let's say regression, something like that, right? And so it creates the object. Then you have to feed it the data, fit it, predict, and then do print stats. So you have to do that repeat this for, let's say I'm going to say here, repeat with 4 other machine learning algorithms and compare results. Basically, you want to say which one performed the best. All right, so that's kind of part of this analysis. All right, so obviously what that means is, for every algorithm, you run print stats metrics. So right now, for every one, we have an accuracy of 98%. So let's say that on logistic regression, the accuracy was 99%. So then, based on that, based on this simple experiment, you would argue that logistic regression does better than SVM. That's kind of what it is. All right, but accuracy is actually not in one of the previous lectures we discussed the differences between accuracy and all the other metrics, and accuracy is not always the greatest metric to use. So there's really no best one. It just depends on the scenario. So that's why it's good to always look at all the metrics and see that it's basically your algorithm is performing well for all of them. So let's add a few of the other ones to this function. All right, so let's say we are going to add the F1 measure. All right, so the F1 measure. Okay, so to do that, we're going to do print F1 measure. So print F1 measure is, and then again the same approach, percentage dot. Let's say that here we do 3F instead of 2F. All right, we add the percentage here, and then we indicate what we are doing. So I'm going to do, everything okay, guys? All right, so I'm going to do, after the percentage, F1 score. So if you notice, this F1 score is really one of the things that we imported in the library. So you can see that here, F1 score. All right, F1, as I said, is another type of metric. Here we're not so concerned with the differences, just to know how to get these values. But it's the same idea, so we do F1 score, parentheses, and now we specify a few parameters. So we can say for y true, so these are the default parameters. This is another way that you might see this written. So y true will be, or let's just skip that. Let's keep it consistent. So I'm going to do y test, comma, and then y pred again, right? So let's just do that. All right. So let's try now F1 measure. All right, so let's go ahead and test this out. So I'm going to do Control X, Y, enter, run it. All right, so here I tried to just use the default values and I got an error. All right, so it's actually the value is here. The suggestion, it's saying that the error was caused because the target is multi-class, but I'm using for the F1 measure an algorithm called binary, right? So, or for binary classes. Instead, I need to choose another algorithm to solve this. What multi-class indicates is that I have 3 classes, 0, 1, and 2, And so if this had been a binary, I could have used that default algorithm, but because it's a 3-class problem, I have to change a parameter. So what I'm going to do is I'm going to go back to the script, and I'm going to go to the function here. And at the very end, I'm going to pick another algorithm. I'm going to say the average method to solve this should be, instead of binary, weighted. So I'm just going to type wait. I think the spelling is correct. All right, so now hopefully it'll work. So I'm going to hit Control X. There we go. I'm going to clear this. Hit Python. And there we go. So now it does work. And now I have, if you notice, 98. Now keep in mind I'm using 3 digits here and 2 digits here. So it's possible that they were both the same. So there hasn't been, but this is good. It's, you know, the way that you can interpret this is that you can say, well, it's good because accuracy is high and F measure is high. Right? And so that's really what we're trying to figure out. So now the next step is just to add the other functions. So we're going to go over here, and I'm going to do print. I'm going to add another one. So in this case, I'm going to do recall. So I'm going to do print recall. And again, %.3f. Okay, %.3f. And now the variable is going to be recall score, which is also another one of the modules I imported in the import section. Recall score. Again, I give it the same parameters basically, y test, comma, y pred, comma, and the method average equal will be weighted again. Weighted. Okay? So now this function, print_stats_metrics, is a function that you always use. Whether you're using sklearn, you can even use it with TensorFlow. And so what I would recommend is that there should be some scripts that you keep somewhere, like in your GitHub or in your flash drive or somewhere that you're constantly referencing. So you don't have to, you can even copy paste because this function rarely ever changes once you've written it. So you'll see me how I'm, in this video, I'm typing it once just to explain everything, but the next time around I'm just going to copy paste it in to everything. So I'm going to keep these files accessible. They should also be in the documents that we provided, like in the slides or in the lab, so you can always copy paste them from there as well. All right, so now that I've created this one, I'm going to do the last one, which is the precision. So I'm going to create print precision %.3f, %.3f, and then precision underscore score, and it's the same idea basically. Y test, Y pred, comma, comma, average equal weighted. And then add the last parentheses again. All right, so we've completed these three. Now let's go ahead and run them. Let's see if it doesn't give us any errors. Okay, so there it is. The done, basically, if you print that out, there were no errors. And so now you see, okay, accuracy was 98%, F1 measure was 978, recall was 978, precision was 980. So you can see there's slight variation. This is uncommon for like real world data sets. Iris is a very simple, very academic data set that has been created just so that we can get the feeling for how everything works. So you can see these are pretty consistent. But overall, the machine learning algorithm learned really well. All right, so now we really just have one more. metric, which is called a confusion matrix. But it's actually a very, very important metric because it tells you basically how things are classified and, more importantly, how things are misclassified. Right? So sometimes there might be a confusion, where you have 10 classes, but class 1 and 7 sometimes are always confused. And that gives you some additional insight as to what's going on. So to solve this, I'm going to go here again. We just need to add now the information for the confusion matrix. This does take a little bit more to solve, so I'm going to create the object conf mat, right? So the confusion matrix basically. I'm going to assign to it confusion matrix, which is from the library. So confusion matrix. This is the same as before. We take y test, comma, y pred. So y test and y pred. All right, and we're going to compare them. All right, and then we can print out the result. So I can do something like print conf mat. So print conf mat. All right, so I'm going to go ahead and now run this. So if I run it, and there you go. You can see it actually now gives us the confusion matrix. Now this confusion matrix is nice, but it's not so intuitive because what do we know here? There's 3 classes, so that tells you, okay, the diagonal usually means that whatever is class A was classified as A, whatever is B is classified as B. So there was really no errors except for this one, the number 1 there. However, we can do a little bit better than this, right? So here, let's take another approach to creating a confusion matrix. All right, we're going to use the same object, but we're just going to print it out a little bit more friendly, more readable. All right, so let's see. To do that, we can use pandas. If you remember at the beginning, we imported the library pandas as PD here. Right? This is, as I said, a very important, very powerful library for data preprocessing. Let me save this before I lose everything. Okay. So we can use pandas to basically create, a better, more readable confusion matrix. So to do that, all we have to do is call the print function, call pd.crosstab, right, which is a function for pandas to, put columns and rows in like a table. And then we give this the y-test data, y-test, y-test, and y-pred, and we can label the rows by saying row name, or row names, equal true, then column names equal predicted. We can also put in like margins here. So we can say margins equal true. All right, and that should be it. So that gives us just a slightly more presentable view of our confusion matrix. So let's run this. So Control X. And so here it's a little bit better now, right? We have the same information as we had here before, right? You know, the same diagonal, 16, 17, 11, with the same misclassification error, 1, except that now we have totals and we have, you know, different things like that. We have the labels here, 0, 1, 2, and 0, 1, 2. So it just makes it a little bit more presentable just by adding that simple line of code. Right? The last part in the code is, what if you wanted to plot your data? Okay, so this is basically the algorithm. So we've defined how to do SVM. We've defined the function print_stats_metrics, which basically gives us our results. So now we want to evaluate iris. We can just run it. So I hit Control X. Then I'm going to do Python. Right? And by doing this, now I have an assessment. So I gave it 70% of the data to train using support vector machines, and then we evaluated the support vector machines model on 30% of the data, and we got these metrics: accuracy of 98%, F1 measure of 0.978, recall of 0.978, precision of 0.98, and the confusion matrix, as you can see here, where we have the predicted values to the actual value. So if it's a 0, so basically this means out of 16 that we had, 16 were correctly classified as 0. Out of 18 that we had for 1, we classified 17 of them correctly, but 1 was misclassified. And then out of 11 that we have for class 2, all 11 were correctly classified. So you can see 0, 0 here, so all of them, all the 11 were classified correctly. So that's how you can interpret the confusion matrix, and it's very useful. So these are the metrics that we use, and that basically concludes today's example. What's left for the student now is to practice this by adding 4 more algorithms. So we did SVM. So obviously think of the logic here, and you would have to implement, repeat this with 4 other machine learning algorithms and compare the results. So I suggest logistic regression and other algorithms. You can refer to the slides and to the course material for additional help in case the algorithms are slightly different. And that basically concludes this discussion.